calendar. We did all the matrices yesterday so that we could do part 1 of vectors today and part 2 of vectors tomorrow. And then that'll also buy us some review time tomorrow as well. Plus it's a block day, so this schedule, this week's all messed up. Alright, so unit 15, day 2, vectors part 1, I guess. There we go. Alright, first a definition that you know from Despicable Me. Alright? There you go. A quantity with magnitude and direction. I'd like to think you know that from physics as well, but maybe you know it more from Despicable Me. It's about this point every year someone suggests we watch the movie because it's an informative and educational movie to help us learn what vectors are. Like, yes and no. Yes, it is that movie. No, we are not watching the movie. So the vector has magnitude and direction, and maybe what helps understand that more than just those two words is vector as compared to a scalar. A scalar is a quantity with only magnitude. And the classic example from physics anyway is velocity is a vector, speed is a scalar. Right? Like, what is your speed? 30 miles an hour. What is your velocity? 30 miles an hour north, or 30 miles an hour south, or there's some direction associated with it. So vector has magnitude and direction. If it doesn't have direction, then it's not a vector, it's just a scalar. A lot of this you'll have done sort of in physics, but I think it's a little bit different take on it. This, at least way back in the day when I taught physics, you definitely did this in physics. Adding graphically. It's like this is one of the first things you do, I think. You like get out rulers and protractors and very carefully add vectors. Sketch one vector, and then from the end of that, sketch the next one. Yes or no? Yes? Okay. So, 2 pieces of good news. The first one is you already know how to do that, at least sort of. You've done it before. The second piece of good news is that in here, it's more conceptual, less. There's less emphasis on accuracy, quite frankly. It's like we're not going to use rulers and protractors. You're going to eyeball it, and I'm going to eyeball it. And we're going to be like, all right, you're good, because we eyeballed it the same, and we're okay. So as long as you're in the ballpark, you'll be fine. So no rulers necessary. Let's say that's vector A, and that's vector B. Vectors, because not only do they have a length, they have a direction. They've got an arrow associated with them. So A plus B. Vectors are kind of like following directions, right? You travel A and then you travel B, but you don't do B until you get to the end of A, right? So let's draw A, and again, no protractors or rulers. We're just sort of eyeballing. A looks like that, so that looks like A to me, right? This the same length, it's parallels, pointing the same way. And then B, I need to attach to the end of it. So there's B. So if you think about following these as directions, you walked A and then you walked B, and your resultant which goes from where you start to where you finish, that arrow or that vector is a plus b. The resultant. I don't know who decided to put the extra a and t on the end of that. Why can't you just call it the result? I don't know. Resultant sounds fancier, I guess. So the resultant vector is that's the answer. Right? If I say do a plus b and you only graph a plus b, that's like me saying I need you to add 2 and 4. And you say, oh, I know how to add 2 and 4. That's 2 plus 4. Like, well, yes, but you're not done yet. You got to finish the problem. That a plus b answer resultant is equivalent of the answer 6. So I don't think it's as big a problem as it used to be, but I would say draw a plus b, and students would do the a plus b, but they wouldn't draw the answer. It's like you got to include the answer as, that's your answer. Otherwise, you're just setting it up, like 2 plus 4. Like, well, you're not wrong, but you haven't answered the question yet. Let's get tricky and do 2a minus b. So I need to draw 2 a's, and then we don't really subtract vectors, we just draw negative vectors. So let's draw 2 a's first. Again, we're eyeballing. I guess if you wanted to get a ruler, you could. There's 1a. There's the second a. And then a negative b. Do you know what a negative b would look like? Yeah, straight up, because it would be the opposite direction of b. So it would look the same, except the arrow would be on the other end. So negative b is up. So we don't really subtract vectors, we just add negatives. So there's negative b. And again, the same commentary about, okay, that's all correct, but the answer's not there yet. You need to go from start to finish. So there's 2a minus b, and that is my answer. And make sure your arrow goes from start to finish. So you don't ever end up with a circle. It's from where you start to where you finish. All right, again, that should have been mostly review from physics, but a high-level conceptual review. We're not getting out protractors and measuring things. So that does leave me a little bit of a judgment call. Like if you do 2a minus b and you say, well, that's a and that's a and minus b is that, I'm going to be like, no, that's not really close. Like you doubled the length of b and halved the length of a. Like you got to be in the ballpark. I'm not getting a ruler out either, but you need to be in the ballpark. That's adding graphically. Next, let's add numerically, meaning adding components. This is sort of what you do in physics. You break it down into the x pieces and y pieces and add up the x's and add up the y's. Assemble them back together. Let's say that vector u, and sometimes our vectors are noted with a bold letter. And with brackets, well, not brackets, but like pointy parentheses. I don't know what the name of that thing is. It's not brackets, not parentheses. Does that have a name? Anybody know if that has a name other than pointy parentheses? So let's say vector u is negative 2, 5, and vector v is 1, 2. That's the x and y components of those vectors. So vector u means go left 2 and up 5. So there's vector u. By the way, they don't have to start at the origin. They start wherever you want them to. Those are more like directions. Down 2 or left 2 and up 5. Vector v, in fact, I probably shouldn't have even drawn it at the origin. I should just draw it from wherever you want. This would mean go right 1 and up 2. Right 1, up 2. There's vector v. Right, now let's find 3u plus 2v. So in the last section, adding them graphically, I would sketch 3 u's and then sketch 2 v's and then draw the full resultant. But there's an easier way if we have the numbers to go here. So 3 times u, which is negative 2, 5, plus 2 times v, which is 1, 2. Now, those aren't parentheses. They're the pointy bracket thingies. But what do you think we do with the 3 and the 2? Distribute. So it works like you think it would work. At least I hope you think it would work that way. So negative 6, 15 plus 2, 4. After we distribute the 3 and the 2. And then we'll add, this is where there's a sort of a link with matrices. When you add matrices, you add corresponding parts. Same thing when you add vectors. We'll add the x's together. So negative 6 plus 2 would be negative 4. And then we'll add the y's together and get 19. So that's my answer to 3u plus 2v is negative 419. That means if I traveled 3 u's and 2 v's, my net change would be 4 to the left and 19 up. This is way better than doing it by hand and drawing it out. Easier and more accurate. All right, last Roman numeral, length, norm, magnitude. The good news is those are all the same thing, just different ways to ask for it. Length probably makes the most sense. Magnitude probably makes sense as well if you think magnitude and direction. So magnitude is how long is the vector, and norm is the fancy word in vector land for how long is it. Like, why couldn't they just call it length? Well, there's a long story, but it basically means length. So let's say vector u is negative 2, 5. And we want the length of u. The length of u. Well, first the symbol for that, rather than just saying we want the length of, like always in math, there's just some symbol to make things, I guess, easier to write anyway. And the symbol is 2 bars on either side of the vector. Length of u means, the 2 bars just means how long is u. Well, there's an equation, but I bet you could figure it out without even looking at the equation. If u means go left 2 and up 5, so left 2, 1, 2, 3, 4, 5, and up 5, so that's u.
left 2, and I went up 5.
I bet you know how to find how long that vector is. If this is a right triangle, a squared plus b squared equals c squared. So it's maybe a new name and a new symbol, but the formula is definitely one you're familiar with. The square root of a squared plus b squared. So 4 plus 25 is 29. So the length of u is square root of 29. You did this in physics as well, right? Like you called it x and y probably. Fx, Fy, and then the total force or the net force. All right, let's do a couple more examples. Let's say u is equal to. There's another way to give the symbol for x and y. Instead of using the parentheses format, you can use I and J format. So we're redefining who u is. U is 3i minus 2j. That's the same thing as 3 negative 2. I just means x direction, j means y direction. So it kind of just depends on preference, if you like i's and j's, or if you like the pointy parentheses thing. They mean exactly the same thing. And every year there's like 1 or 2 students who really prefer one or the other, and so they'll change every single problem to the form that they like, which is fine. Most students are plenty comfortable realizing, yeah, that's the same thing. I don't care what format it's in. It's x and y. Whether it's i's and j's or in a parenthesis style, it's x and y. Let's say vector v is negative I plus 5j. And again, you don't have to change it, but if you prefer, you could write that as negative 1, 5. Alright, we're going to find 2 things, related things, but not the same thing. So we're going to find this, and then we're going to find this. Can you put into words what the difference between those 2 things is? Like, they're both u minus 2v, but this one's got those bars around it. What do the bars mean? Length. So, didn't say this earlier, but length is not a vector. It's just a number. It's a scalar. So when you find length, you just give one number. How long is it? 12, square root of 29, whatever. Just how long it is. But this one, u minus 2v, this one's going to stay a vector. So let's do this one first, and then this one will sort of lead to this answer. So u minus 2v. I guess we did some math with parentheses earlier, so I'll do it in IJ format, but it really doesn't matter. 3i minus 2j, because that's u, minus 2 times negative I plus 5j. Let's distribute the negative 2. So plus 2i minus 10j. When we added with parentheses or with matrices, we added by position. Here, there's not really position. It's more like terms. So it's the same thing. You're still adding the x's, but instead of adding the first numbers as the x, you're adding the i's as the x. 5i minus 12j. And that's our answer. So if we traveled u and then traveled backwards v twice, we would have gone 5 to the right and 12 down. 5 in the x direction, negative 12 in the y direction. If you liked it the other way, or if you wanted to work it the other way, then your answer might look like 5, negative 12 in the pointy brackets. And I'm okay with either one. Like that's the same thing. To me, that's really easy to tell. So if you've got a preference, then go with your preference. Okay, so that's a vector. Number 2 says, what's the length of that vector? So I already know what u minus 2v is. So I want the length of 5i minus 12j. Or the length of 5 comma negative 12. Many of you, maybe most of you, are going to jump straight to the formula. A few of you are still sort of trying to visualize what that means. Well, it means go right 5 and down 12. So there's my vector, and I want to know how long it is. Oh, that one's recognizable? Right triangle? Yes? 5, 12, 13. If you get one that you don't recognize, then you have to do a squared plus b squared. But that one's just 13.
Is calculator allowed on all parts of the test?
Or just I think calculator will be allowed to make sure you don't mess up the silly, simple stuff like that.
But
Yeah.
on the test, could we just write 13?
Yeah. Yep. Probably many of you would. You know that you do a squared plus b squared, or you might recognize, wait a minute, that's 5, 12, 13 triangle, so the answer is 13. So we're done, but I do want to pause and look at the difference between these two again. U minus 2v, that's going to be a vector answer. We got a vector for an answer. The length of u minus 2v meant I had to do u minus 2v first, so we'd kind of already done that, and then we found the length of them to be 13. You know what? Let's do one more. Said we're done. I lied. What about that? Is that going to be 13? It's like, I don't know, maybe, but not necessarily. The length of u minus the length of 2v. So the length of 3, negative 2, minus the length of negative 2, 10. And I switched back to parentheses rather than i's and j's, because it doesn't matter. You can use either one you like. So, again, you draw the picture if you like, but 3 squared plus 2 squared is 13. And then 2 squared is 4, plus 10 squared is 100. So square root of 13 minus square root of 4. I don't think that's 13. I don't know what that is, but not 13 is a safe bet. So be careful what's asked. It's those 3 things that sort of confuse people. Here we found just the vector, then we found the length of that vector. But this last one we found the lengths first and then subtracted. So be careful when you're on worksheet 3. It is just one page. Vectors worksheet, part 1. Define the term. We did that already. A few drawing, a few with math. But again, be careful because you got links, you got vectors, you got links of vectors. And then kind of the same thing down here. Vectors, vectors, links of vectors. So not hard, but do be careful. Tomorrow we'll add in one new formula, and then we'll be done with this unit.